Meet Marcus. He's 11 years old, and he just got the coolest assignment ever. Design a floor plan for his dream bedroom. But there's one problem. His bedroom is 15 feet wide, and his paper is only 15 inches wide. How is he supposed to draw that? Today, we're going to crack this mystery together and discover the amazing math behind every map, blueprint, and scale drawing you've ever seen. Let's go. So what exactly is a scale drawing? It's a drawing of something real, like a room, a building, or a whole country, where every single measurement has been shrunk down by the same amount. That word, same amount, is the key. Because if you shrink some parts more than others, your drawing becomes a crazy distortion. Scale drawings keep everything in perfect proportion, so the drawing looks exactly like the real thing, just smaller. Think of it like zooming out on your phone's map app. Here's the secret code of every scale drawing: the scale ratio. It tells you the relationship between the drawing and real life. For example, if the scale says 1 inch equals 10 feet, that means every single inch on the paper represents 10 real feet in the actual room or building. This ratio is called the scale factor. The formula is simple. Scale equals drawing length divided by real length. Marcus sees this on his blueprint assignment, and suddenly it starts to click. Now here are your two power formulas, and they're honestly really simple. If you know the measurement on the drawing and you want to find the real-life size, you multiply by the scale factor. Going the other way, if you know the real-life size and want to draw it on paper, you divide by the scale factor. That's it. Multiply to go from drawing to reality. Divide to go from reality to the drawing. Marcus wrote both of these on a sticky note on his desk. Smart kid. Let's try Marcus's first map problem. The scale on his city map says 1 inch equals 5 miles. He measures the distance from school to the park. It's 3 inches on the map. What's the real distance? We use our formula. Real length equals drawing length times scale factor. So that's 3 inches times 5 miles per inch. 3 times 5 equals 15. The real distance from school to the park is 15 miles. Marcus pumps his fist. He got it on his first try. Now let's go the other direction, from real life to the drawing. Marcus wants to draw his bedroom wall, which is 12 real feet long. His blueprint scale is 1 inch equals 3 feet. How long should he draw the wall? We use drawing length equals real length divided by scale factor. That's 12 feet divided by 3 feet per inch. 12 divided by 3 equals 4. So Marcus draws the wall as 4 inches on his blueprint. Perfect. It fits right on his paper. Here's something cool. Scales can also be written as ratios, like 1 to 100 or 1:100. This means 1 unit on the drawing equals 100 of those same units in real life. So if you measure 1 centimeter on a blueprint with a 1 to 100 scale, the real measurement is 100 centimeters. That's 1 meter. Architects and engineers use this format all the time. Marcus spotted this exact notation on a real blueprint his dad brought home from work. Pretty professional. Let's tackle a ratio-style scale. A blueprint uses a scale of 1 to 50. Marcus measures a hallway on the blueprint as 8 centimeters. What is the real length of the hallway? With a 1 to 50 scale, every 1 centimeter on the drawing equals 50 real centimeters. So, real length equals drawing length times scale factor. That's 8 centimeters times 50. 8 times 50 equals 400. The real hallway is 400 centimeters, or 4 meters long. Marcus is getting really good at this now. What if the scale isn't given and you have to figure it out? No problem. You just divide the drawing length by the real length. But here's the important part. Make sure both measurements use the same units before you divide. For example, if the drawing shows 5 inches and the real object is 10 feet, You'd first convert 10 feet into 120 inches, then divide 5 by 120 to get the scale factor. Marcus had to do this exact step when comparing two different blueprints. Tricky, but totally doable. Time to find a scale factor from scratch. A drawing of a football field measures 2 inches on paper. The real football field is 100 yards long. First, convert to matching units. 100 yards equals 3,600 inches. Now divide. Scale factor equals 2 divided by 3,600. Let's simplify. Both 2 and 3,600 are divisible by 2. That gives us 1 divided by 1,800. So the scale is 1 to 1,800. For every 1 inch on the drawing, the real field is 1,800 inches long. Incredible. Okay, back to Marcus's original challenge. His bedroom is 15 feet wide and 18 feet long. His blueprint scale is 1 inch equals 3 feet. How big should his bedroom rectangle be on paper? For the width, 15 feet divided by 3 feet per inch equals 5 inches. For the length, 18 feet divided by 3 feet per inch equals 6 inches. So Marcus draws a rectangle that is 5 inches wide by 6 inches long. He looks at it and grins. His dream bedroom fits perfectly on the paper. From confused to confident. That's Marcus. Scale drawings are literally everywhere once you know what to look for. Maps shrink entire states or countries down to fit on a page. Architects use blueprints to plan every detail of a house before a single nail is hammered. Scientists use scale models to study things as small as molecules or as huge as the solar system. And here's a fun one. Video game designers use scale maps to build every virtual world you explore. Marcus realized scale drawings aren't just a math topic. They're a superpower used across every career you can imagine. Let's bring it all home. Remember when Marcus stared at that blueprint assignment totally stumped? Now he can design his bedroom like a pro architect. Here's your quick recap. The scale tells you how drawing measurements relate to real life. To find real length, multiply drawing length by the scale factor. To find drawing length, divide real length by the scale factor, and always make sure your units match before calculating. Scale drawings are one of those math skills that you'll use forever in art, science,